Have you ever stood by the shore, mesmerized by the endless rhythm of the waves? The constant ebb and flow, the powerful crash, the gentle lapping. It feels like the very pulse of our planet. But what if one day that pulse just stopped? What if the oceans, all across the globe, suddenly became perfectly still? It sounds like a scene from a sci-fi movie, but let's dive into this thought experiment together. What would actually happen if the ocean stopped moving? First, let's understand what keeps the ocean in motion. It's not just one thing, but a complex dance of forces. We have the wind, which whips up surface waves and drives major currents. We have the tides, caused by the gravitational pull of the moon and the sun. And then we have the big one, the global conveyor belt, a massive system of deep ocean circulation driven by differences in temperature and salinity, what scientists call thermal circulation. All these elements work together, constantly churning and mixing the vast waters of our world. So, imagine a switch is flipped. All these forces vanish. The first thing you'd notice is the silence. The familiar roar of the surf would be replaced by an eerie, profound quiet. The coastline would transform into a flat, glassy mirror, reflecting the sky with unnerving perfection. It might look peaceful, even beautiful, for a moment. But this tranquility would be the calm before a global catastrophe. The most immediate and devastating impact would be on marine life. Ocean currents act like a planetary circulatory system. They transport oxygen from the surface, where it's produced by phytoplankton, down into the deep sea. Without this delivery service, the deep ocean would quickly become an anoxic zone, a dead zone. Creatures living in the abyss, from giant squid to bizarre-looking anglerfish, would suffocate. But the problem isn't just in the deep. Currents also carry nutrients, like a massive soup ladle stirring the ocean. They bring essential minerals up from the depths to the sunlit surface waters. This process, known as upwelling, is the foundation of the entire marine food web. Phytoplankton, the microscopic plants that form the base of the food chain, depend on these nutrients. Without upwelling, phytoplankton populations would plummet. And when phytoplankton die, everything else follows. Zooplankton that eat them would starve. Small fish that eat the zooplankton would disappear. And so on, up the food chain, all the way to the top predators like sharks, dolphins, and whales. Our vibrant, teeming oceans would turn into a desolate, aquatic desert. The fishing industry, which feeds billions of people and supports millions of jobs, would collapse completely, triggering a global food crisis of unimaginable scale. But the consequences wouldn't stop at the water's edge. The oceans are the planet's primary climate regulator. They are Earth's thermostat. Ocean currents act like a massive heat distribution network, absorbing heat in the tropics and transporting it towards the poles. The Gulf Stream, for example, carries warm water from the Gulf of Mexico across the Atlantic, which is why Western Europe enjoys a much milder climate than, say, parts of Canada at the same latitude. If this heat transport stopped, the world's weather would go haywire. The tropics would become unbearably hot. Without the ocean to absorb and carry away excess heat, equatorial regions could see temperatures soar to scorching, unlivable levels. Life there, both on land and in the shallow seas, would be baked. Meanwhile, the polar regions and temperate zones would plunge into a deep freeze. Without the influx of warm water, places like the United Kingdom and Scandinavia would experience brutal, Siberian-style winters. Glaciers and ice sheets would expand rapidly, reflecting more sunlight back into space and accelerating the cooling. The world would become a planet of extremes, a fiery equator and frozen poles, with very little habitable land in between. The impact on our weather patterns would be chaotic. The temperature difference between the equator and the poles is a major driver of atmospheric circulation, creating winds and storms. With this temperature gradient becoming so extreme, we could see the formation of hyperhurricanes and megastorms of unprecedented violence along the boundaries of these new climate zones. Coastal areas, once defined by gentle sea breezes, would now face either stagnant, suffocating air or catastrophic wind events. Rainfall patterns would shift dramatically, leading to severe droughts in some areas and biblical floods in others. Agriculture worldwide would fail. And we haven't even talked about oxygen yet. We all learn in school that rainforests are the lungs of the planet, but that's only half the story. It's estimated that phytoplankton in the ocean produce between 50 to 80% of the oxygen in our atmosphere. A stagnant, lifeless ocean means a massive reduction in this oxygen production. Over time, the very air we breathe would begin to change. While we wouldn't suffocate overnight, the slow decline in atmospheric oxygen would have profound long-term effects on all air-breathing life, including us. It would feel like living at a high altitude all the time. Another terrifying consequence would be at the coastlines. We mentioned the tides stopping. The moon's gravitational pull creates tidal bulges on opposite sides of the Earth. Without the Earth's rotation and oceanic movement to spread this water around, the water would redistribute. It would pool at the poles and recede from the equator. A new, permanent global sea level would establish itself. This would create a massive megacontinent around the Earth's belly, as vast areas of the ocean floor are exposed. Meanwhile, coastal cities at higher latitudes would be permanently submerged under hundreds of feet of water. London, New York, Tokyo gone. It would be the greatest displacement of humanity in history. A new land bridge at the equator would connect continents in strange new ways. You could theoretically walk from Brazil to Indonesia. But this new land would be a barren, salt-encrusted wasteland, a dead seabed exposed to the sky. And the stagnant water that remained would become a toxic soup. Without circulation, pollutants, sediments, and decomposing organic matter would just sit there. The ocean would become a putrid, stinking swamp on a global scale, releasing harmful gases like hydrogen sulfide and methane into the atmosphere. So, a motionless ocean isn't a peaceful paradise. It's a doomsday scenario. It would trigger a chain reaction that would dismantle our planet's life support systems one by one. The food web would collapse, the climate would spiral into deadly extremes, and the very composition of our atmosphere would change. It's a stark reminder of how interconnected everything is. The slightest movement of water in the deep Pacific can influence the weather in Paris. The microscopic life in the Southern Ocean helps you take your next breath. Our planet is a dynamic living system, and the ever-moving ocean is its lifeblood. The constant churn is a sign of health, of a world in balance. The day the ocean stops moving is the day our world as we know it begins to die. It really makes you appreciate that rhythmic sound of the waves, doesn't it? It's not just noise. It's the sound of our planet being alive. Have you ever been caught in a storm so intense it felt like the world was ending? Or sweltered through a heat wave that seemed to melt the very air you breathe? We often think of weather as just a daily forecast, something to check before we get dressed. But what happens when the weather breaks? Welcome to our journey into a planet of extremes, where we'll explore the most powerful, destructive, and frankly, terrifying weather phenomena our world can throw at us. From the spiraling fury of a Category 5 hurricane to the silent, creeping danger of a drought, extreme weather is becoming more frequent and more intense. But why? Is this just the Earth's natural cycle, or is something else at play? We'll be diving deep into the science behind these events, separating fact from fiction, and looking at the very real impact they have on communities and ecosystems around the globe. Or, depending on where you are, a typhoon or a cyclone. They're all the same beast, just with different regional names. Imagine a massive rotating storm system, hundreds of miles wide, with winds screaming at over 150 miles per hour. These giants are born over warm tropical oceans, where the heat and moisture act as fuel. Think of it like a colossal heat engine. Warm, moist air rises, creating an area of lower pressure below. Air from surrounding areas with higher pressure pushes into the low pressure area. Then, because of the Earth's rotation, this swirling air begins to spin. The eye of the storm, that eerily calm center, is where air from high up in the atmosphere sinks down. But don't be fooled by the quiet. Surrounding the eye is the eye wall, the most dangerous part of the hurricane, where the winds are at their absolute strongest and the rain is the heaviest. The devastation from a major hurricane comes from a triple threat: the ferocious winds that can tear buildings apart, the torrential rain that leads to catastrophic flooding, and the storm surge, massive wall of water pushed ashore by the storm's winds, capable of inundating entire coastal cities. We've seen the horrifying power of storms, like Hurricane Katrina in 2005, which devastated New Orleans, and more recently, storms that have rewritten the definition of intense. Scientists are observing a clear trend. While the total number of hurricanes might not be increasing dramatically, the ones that do form are more likely to become major, powerful storms. Now let's shift from water to fire. Wildfires have always been a natural part of many ecosystems, clearing out old growth and allowing for new life. But the wildfires we're seeing today are different. They are bigger, hotter, and more destructive than ever before, earning the name megafires. What's causing this terrifying shift? It's a dangerous cocktail of conditions, often summed up as hot, dry, and windy. All it takes is a single spark from a lightning strike, a careless campfire, or even a downed power line to ignite a blaze. When you add high winds to this equation, the fire can spread with terrifying speed, jumping across roads. Take the 2019 to 2020 bushfire season in Australia, known as the Black Summer. Similarly, California and other parts of the American West have been battling increasingly severe fire seasons year after year. The link to our changing climate is undeniable. Higher average temperatures mean less snowpack in the mountains, which is a vital source of moisture for the summer. But extreme weather isn't always about fast, violent events. Sometimes it's a slow, silent crisis. Let's talk about heat waves. You might think a few hot days are just an excuse to go to the beach, but an extreme heat wave is a public health emergency. When temperatures soar and stay high for days or even weeks, the human body struggles to cool itself down. This can lead to heat exhaustion, heat stroke, and can be fatal, especially for the elderly, children, and those with pre-existing health conditions. In 2003, a massive heat wave swept across Europe, leading to tens of thousands of deaths. More recently, in 2021, a heat dome settled over the Pacific Northwest of North America, shattering temperature records. Places known for their mild climates saw temperatures that were more typical of a desert, with devastating consequences for people and infrastructure not built to handle such extreme heat. These events are becoming more common and more intense. What used to be a once-in-a-century heat wave is now happening every few years in some regions. From fire and heat, we turn to the other extreme: floods. While hurricanes bring coastal flooding, inland floods are a different, but equally dangerous phenomenon. Extreme rainfall events, sometimes called rain bombs or atmospheric rivers, are overwhelming drainage systems and riverbanks. An atmospheric river is like a conveyor belt of moisture in the sky, a long, narrow band of concentrated water vapor. When one of these makes landfall and is forced up by mountains, it can dump an astonishing amount of rain or snow in a very short period. This kind of event highlights a fundamental principle of climate change. A warmer atmosphere can hold more moisture. So, we have more powerful hurricanes, bigger wildfires, more intense heat waves, and more extreme rainfall. The first step is acknowledging what's happening and why. By understanding the science behind these extreme weather events, we can better prepare for them. This means building stronger, more resilient infrastructure sea walls to protect against storm surges, better forest management to reduce wildfire risk, and improved water management systems to handle both droughts and floods. It also means developing better early warning systems to give communities time to prepare and evacuate. On a personal level, being aware of the risks in your area is crucial. Do you live in a floodplain? A wildfire-prone zone? A coastal area? Having a plan for your family in case of an emergency is more important now than ever before. But adaptation is only one half of the solution. The other, more critical half, is mitigation. Reducing greenhouse gas emissions by transitioning to clean energy sources like solar and wind, improving energy efficiency, and protecting and restoring our natural ecosystems like forests and wetlands are all essential pieces of the puzzle. The weather has broken its old patterns. We are now living in an era of climate extremes. The challenges are immense, but so is our capacity for innovation and cooperation. By learning from these events and working together, we can build a safer, more resilient future on our beautiful and sometimes terrifying planet. What we do in the next decade will determine what the forecast looks like for generations to come. Imagine a world where the coastlines we know and love are gone. Venice, Miami, Shanghai, all submerged beneath the waves. It sounds like science fiction, but with rising sea levels, this is a future scientists are seriously considering. But here's the twist. It's not the end of the world. It's the beginning of a new one. Where would we live? What would our cities look like? Today, we're embarking on a journey to explore the new coastlines of a future Earth, uncovering the surprising and resilient new centers of human civilization. Get ready, because the world map is about to be redrawn. First, let's get a handle on the scale of this change. We're talking about a future where all the ice on Earth is melted. This would raise sea levels by over 60 meters, or about 216 feet. That's enough to completely inundate coastal regions worldwide. Florida would be almost entirely underwater. The Amazon basin would become a massive inland sea. The Netherlands, Denmark, large parts of the UK gone. In Asia, Bangladesh would be erased, and coastal China would be devastated. It's a staggering transformation, but humanity is adaptable. We've always moved, always settled new frontiers. This would be our greatest migration yet. So, where do we go? The key is elevation. The new hotspots for human settlement will be the world's high-altitude plateaus and mountain ranges. Let's start in North America. The Appalachian Mountains, one of the oldest mountain ranges on Earth, would become a sprawling eastern coastline. Cities like Pittsburgh, once an industrial heartland, would suddenly find themselves with beachfront property. Imagine West Virginia's rolling hills cascading down to a new Atlantic shore. Out west, the Rocky Mountains would become a massive, rugged island chain. Denver, the mile-high city, would be a major port, looking out over a vast inland sea that has swallowed the Great Plains. The high plateaus of Mexico would also become prime real estate, a central hub of this new North American landscape. Now let's cross the new, wider Atlantic. Europe's map would be almost unrecognizable. The Alps would transform into a spectacular alpine archipelago, a chain of islands with snow-capped peaks rising from the sea. Geneva and Zurich would become breathtaking coastal cities. Spain's central plateau, the Meseta Central, would become a large, elevated island nation, a fortress of high ground in a submerged Western Europe. Scandinavia would fare surprisingly well, with its mountainous spine forming a new rugged peninsula. The Ural Mountains, traditionally the border between Europe and Asia, would suddenly become a crucial land bridge, a continental spine connecting what's left of the two landmasses. This region could become a new powerhouse of trade and culture. Speaking of Asia, the changes there would be monumental. The flooding of Southeast Asia and eastern China would displace hundreds of millions. The new center of gravity would shift dramatically westward and upward. The Tibetan Plateau, often called the roof of the world, would become the world's largest and most important landmass. Its vast, high-altitude plains would be the new heartland of civilization. While the air is thin, this region would be surrounded by newly formed seas, potentially creating a more moderate, monsoon-driven climate over time. Imagine new, sprawling cities built on the shores of a Tibetan sea. Further west, the highlands of Iran and Turkey would become critical landmasses, forming a bridge between the new Europe and the high-altitude core of Asia. What about Africa and South America? In South America, the Andes Mountains would become the continent's backbone in a very literal sense. This long, narrow strip of high ground would be the primary home for the continent's population, looking west over the Pacific and east over the newly formed Amazon Sea. Cities like Bogotá, Quito, and La Paz, already at high altitudes, would become the continent's thriving coastal capitals. In Africa, the Ethiopian highlands would rise like a fortress, an immense plateau island surrounded by water. It's one of the most ancient and geographically stable parts of the continent, and it would become a cradle for a new African civilization. The Great Rift Valley would also form a dramatic new coastline, a geological scar turned into a vibrant coastal region. Australia, the island continent, would become even more of an island. Its vast, low-lying interior would flood, creating a massive central sea. The Great Dividing Range along the east coast would become a thinner but crucial strip of habitable land. The continent's population would be pushed into these elevated coastal zones, living between the mountains and the sea. This would fundamentally reshape Australian life, creating a civilization clinging to the high ground on the continent's eastern and western fringes. It would be a more compact, but perhaps more interconnected society. Now, this isn't just about finding high ground. Building a new world involves immense challenges. We'd need to develop new forms of agriculture suitable for high-altitude environments. We'd have to construct entirely new infrastructure ports, cities, transportation networks on a scale never seen before. Our sources of energy would have to be reimagined. Perhaps we'd harness the powerful tides of these new, vast seas or the winds sweeping across the high plateaus. It would be the ultimate test of human ingenuity and cooperation. Could we do it? History suggests we can. We've built cities in deserts, on frozen tundras, and on tiny islands. This would be our next great chapter. Thinking about this future isn't just a dystopian fantasy. It's a powerful thought experiment. It forces us to appreciate the world we have now and the urgent need to protect it. The choices we make today about climate change will determine which version of the future our descendants inherit. Will they live in a world that looks like our own? Or will they be the pioneers settling these new coastlines? It also highlights our incredible resilience. Even in the face of such a catastrophic transformation, life would go on. Humanity would find a way, creating new cultures, new nations, and new dreams on the high ground of a changed planet. This new world would be a place of breathtaking, unfamiliar beauty. Imagine sailing through the Alpine archipelago, kayaking in the Amazon Sea, or watching the sunset over the new Australian interior ocean. It's a reminder that our planet is a dynamic, ever-changing system. We are just one part of its long, dramatic story. Exploring these possibilities doesn't have to be scary. It can be a source of awe and a powerful motivator for action in the present. The future isn't written yet. Let's work to keep our coastlines right where they are. Thanks so much for joining me on this journey to a potential future. What part of this new world would you want to live in? Let me know in the comments below. And if you enjoyed this exploration, don't forget to like this video and subscribe for more deep dives into the fascinating what-ifs of our world. See you next time.